Educator.com. This lesson is on chemical bonding. This will be part 1 where we learn about types of chemical bonds and how they occur. And this will be followed by part 2 chemical bonding where we learn how to write out the compounds and name the compounds formed by chemical bonds. So let's get started. Atoms will gain, lose, or share electrons to fill their outer energy levels and become stable. This is the whole point in a chemical bond forming, is for an atom to stabilize itself. So if we remember, the outer energy levels are filled with what we call valence electrons. Okay, so if you hear the word valence electrons, you're talking about electrons in the outermost energy level. And these are the ones that are reactive, or the ones that will interact with other atoms and other electrons. The interaction of the electrons between atoms creates an attraction which holds atoms together in a chemical bond. So we have atoms. So I'll draw the nucleus of an atom, just a general nucleus, and the electron cloud around it. Okay, and then I'll draw one over here with the electron cloud here. So if you have electrons in that electron cloud that interact with other atoms. So if this electron here tries to pair with this electron there, what will happen is it will bring those two atoms closer together. And that what's bringing them together is that force of the electrons, and that's what creates the chemical bond to hold the atoms together. Now those electrons could be shared, which is kind of what I drew here. This one will pair up with this one and they're shared. And the other ways are to lose the electron or to gain an electron, and then they create ions, which we did talk about before. We'll get into a little bit more here. When two or more atoms are held together by a chemical bond, what's formed is a compound of two or more atoms held together by a chemical bond. The chemical formula of a compound is the way to describe what's in the chemical compound. It tells what elements and how many of each element are in that compound. So I've written a couple of chemical formulas here, starting with this one, H2O. You might have heard of this before because it's water, very common in your everyday life. H2O, this is the chemical formula for water. The H refers to hydrogen. If we go back to our periodic table, the hydrogen is up here at the top, okay? The first one up there. Hydrogen is H. That's what you have to remember. We were also looking at O, and O is over here in group 16. O refers to oxygen. So if you need help remembering what all these symbols represent, go back and take a look at your periodic table, or we'll show this when I can, and so you'll be able to kind of figure it out. Remember, the symbols stand for the element's name. Okay? So H hydrogen, O oxygen. This means that this compound here has 2 hydrogen atoms and 1 oxygen atom. H2O has 2, and the oxygen is here, and then it's attached to 2 hydrogens, just like that. So this is what the molecule, the compound would look like with the 2 hydrogens and the 1 oxygen, and this is how we write it, H2O. Okay, so we'll take a look at another formula, HCl. HCl, the H is still hydrogen. The Cl, remember that L is lowercase, meaning it's part of whatever that C is. So Cl, if you look at your periodic table, is for chlorine. So this is a hydrogen atom attached to a chlorine atom. And when I draw it out like this, with the H and then a line between and the Cl, it kind of refers to what I was doing up here between those 2 atoms. I'm holding the atoms together in a chemical bond. So when I draw the line between the H and the Cl, I mean that there's a chemical bond between those 2 atoms. Okay, when we get to a more difficult one, we have C6H12O6. So we take a look, okay, there's C, that's for carbon. So there are 6 carbons in that formula. There's H, and there's a 12 right next to the H. There's 12 hydrogens in that formula. And then the O has a 6 next to it, O for oxygen, and there's 6 of them, meaning there's 6 atoms of oxygen. So the subscript written just below and to the right of the symbol tells you how many atoms of that element there are in your formula. So in this one, the C has the 6 as a subscript, The H has a 12 as a subscript, and the O has another 6 as a subscript. So we write it out. It has 6 carbons, 12 hydrogens, and 6 oxygens. The last one is a little bit more complicated because it has these parentheses around it. It has Ca, and then in parentheses, NO3, and then out of the parentheses is a 2. So what this subscript number outside the parentheses is what we call distributed to everything inside the parentheses. You might have seen this in math before, distribution. You multiply that 2 by whatever's in there. So the N has a subscript of 1, which, if you remember, we don't have to write. So if there's no subscript, we know that there's a 1 there. So that 2, you multiply by whatever's in there, so there's 2 nitrogens. You can write that out. Now distribute that 2 to whatever oxygens are in there, and you'll see it's 2 times 3, so there's 6 oxygens. And then the Ca, the calcium, it's outside of the parentheses, so the 2 doesn't go to that one. So there's only actually 1 calcium atom. Okay, and what that would look like a calcium atom here, and attached to that calcium atom would be 2 of those NO3 groups. So whatever's in the parentheses is a chemical group, and it sticks together for this formula. So NO3 there, and an NO3 there. And that's how they would attach to that central calcium. So if you take a look, that's why we put that there's 2 of them, because we have 3 oxygens here, and then we have 3 oxygens right here. And that's what gives us our 6 oxygens in that total formula. There's 1 nitrogen here, and there's 1 nitrogen here, which gives us our 2 nitrogens for that formula. And then, of course, our central calcium there. Okay? So we'll be dealing with these formulas a lot. Remember, the subscript goes to the symbol that comes right before it, and the parentheses keep that group together, and whatever's outside the parentheses goes for everything in the parentheses. All right, so what we need to remember today are dot diagrams, which show us the electrons that an atom has available for bonding. And those are going to be all of its valence electrons. The valence electrons are the ones that are available for bonding. Specifically, the valence electrons that are not paired. So if you remember the dot diagram of hydrogen, okay, there's 1 electron for hydrogen. So there's 1 dot. It has 1 unpaired electron, therefore hydrogen can make 1 bond. 1 unpaired electron. 1 unpaired electron equals 1 bond that hydrogen can make. Okay, something a little bit more difficult, or a little bit able to bond more, would have more unpaired electrons. Something like carbon. Carbon's dot diagram looks like this, with 4 unpaired electrons. 4 unpaired electrons means that carbon can make 4 bonds. Okay, we can tell what electrons are available for bonding by making the dot diagram. And the dot diagram is a diagram of what the outermost energy level of electrons looks like. Okay? And then the other thing we need to review is ion formation. Ion formation is when an atom gains or loses an electron. So hydrogen, with its 1 electron, might actually lose it to become more stable. If hydrogen loses that electron, hydrogen's left with whatever's in the nucleus. For hydrogen, that means there's 1 proton in the nucleus. If there's 1 proton and no electrons, that leaves hydrogen with a +1 charge. And that makes it an ion. So if an atom loses an electron, it's left with a positive charge. If an atom gains an electron, it's left with a if it gains an electron, it has a negative charge. It's gaining negativity by gaining an electron. So if it gains, the ion has a negative charge. And if it loses an electron, it's losing negativity, therefore it becomes more positive. So the ion will have a positive charge. Okay, ion formation, dot diagrams, and chemical formulas. That's really what we're going to get into now.